Hello everyone, this is a problem from the Bosnia Mathematical Olympiads of 2015. This is problem number 2 and this is an algebra problem. I'll give you the solution in 2 seconds. So, first thing which you might want to notice is that the square root of 2015 here is kind of pointless. It is just square root of ABC. So we can just write here ABC and the problem remains the same. Now, another thing which you might want to do is to simply notice that you can kind of simplify the right-hand side and have that square root of ABC plus square root of B, square root of ABC plus square root of C over square root of ABC. And here you can simplify and remove A, remove B, and remove C. And so you get that it is A plus B over A squared plus B squared plus B plus C over B squared plus C squared plus C plus A over C squared plus A squared, which we must prove to be less than 1 over square root of BC plus 1 over square root AC plus 1 over square root AB, where A, B, and C are positive integers. This was given also in the problem, I forgot to write it. Now, you can do something else here, and that should be to simplify the problem even more, and that is if we prove that B plus C over B squared plus C squared is less than or equal to 1 over square root of BC, then we're done, because you can swap B and C with A and C and get the same result, and A and B with B and C. So let's try to prove that A plus B over A squared plus B squared is less than or equal to 1 over square root AB. Now, here I think you can actually write this as AB, A plus B, square root of AB, which is less than A squared plus B squared. You can even bring to the other side and get that it is A squared plus B squared minus A square root of A minus AB minus B square root of AB, which must be greater or equal to 0. This is what you're trying to prove. I simply developed the brackets and brought to the other side. Yes, I did everything correctly up until now. What else can I say? Well, I can try to factorize. A good way to factorize would be to take a square root of A from here and from here. And so we get square root of A minus B square root of B plus, I can do the same thing, square root of B times B square root of B minus A square root of A. And I must prove that this is greater or equal to 0. Now, I can do something else, I think so, because I can write this as minus B and switch the signs here, so, and these two brackets are the same. So I can factorize and have A square root of A minus B square root of B, and that is square root of A minus square root of B. And I must prove that this is greater or equal to 0. Now, first thing which you might want to notice is that this side right here isn't always positive. But when this is negative, also this other stuff here is negative. We can actually prove this by taking the derivative of both sides. And that is, firstly, square root of A with being greater than square root of B means that simply A is greater or equal to B, because as I said, A and B are positive. And so so I can say that square root of A minus square root of B is positive if A is greater than B. If A was equal to B, then this whole thing would be 0, so it would be kind of pointless. Now, and also it can't be 0, because then we would be dividing by 0. Now, what can we do now? Well, we need to prove that when A is less than B, this also is negative. And let's write this as f of x is equal to x times the square root of x, which is equal as x is equal to 3/12. The derivative should be power rule 3/12 over square root of x. Notice that the derivative here is always positive, so which is always positive. So f of x is a strictly increasing function. So for f of x minus f of x1 and x2 to be greater than 0, we must have x1 to be greater than x2. And this proves that when the right hand is negative, also the left hand is, and so it will always be either a negative time a negative, which is positive, or a positive time a positive, which is also positive. And so by proving that this simpler inequality, I can simply say that a plus b over a squared plus b squared is less than this, and I can also say that b plus c over b squared plus c squared is less than 1 over bc, and also say that c plus a over c squared plus a squared is less than 1 plus 1 over square root of ac, and we have just proven our claim. I have also seen our solution using AMGM. I wasn't able to find them. I try only to bring my solutions into this channel, so try if you can get something on your own, but I wasn't able.